All right, this is example D in our lesson 4, rational expressions and functions. That's my dog stretching. So first of all, we're going to be able to identify the domain and the restrictions right away. X cannot be 1. The numerator and the denominator are both already factored, so there's nothing canceling out. So that means the vertical asymptote is x equals 1. So notice how I do restrictions, and I immediately know if I have a vertical asymptote or a hole. We'll talk about what holes are. And I also know the domain. I know it's going to go from negative infinity to 1. It's going to skip over 1 and then continue on. Zeros. When I plug in 0 for the function, I cross multiply and I get x squared equals 0. So the x-intercept is 0, 0. That means the y-intercept has to be 0, 0 as well. So I know this is an important point right here. It's where the graph either touches it and it either goes up and comes back down, or it will get really close and do something funky like that. But we'll see. So now we're going to do the horizontal asymptote. Here we have a case where the degree of the numerator is greater than the degree of the denominator. So the degree of the numerator is greater than the degree of the denominator. And when that happens, we get what's known as a slant asymptote. Not a horizontal, we get a slant. Most of the time it's a line, but it can be a quadratic. And what we're going to need to do to find that is we're going to have to do long division. So imagine that. All that work that you guys did before comes back. So we are going to divide x minus 1 into x squared. I'm going to show that work, but I'm going to erase it so I have some room here. So I'm going to find the equation of the line, that is the slant asymptote, by dividing the denominator into the numerator. And remember how we did this? We did placeholders. X minus 1 goes into x squared, x times, I multiply, then I subtract. This would give me negative 1x. Bring down the plus 0. X minus 1 goes into negative 1x. Negative 1 time. Oh, I made a mistake there. Do you guys see what it is? So I was right to do the double negative, but then this should have been a positive 1, which would make a big difference. So this would be plus 1. And I multiply, get 1x minus 1, and then you subtract, and you get negative 1. So it doesn't go into it evenly, but that's okay. The equation of the slant asymptote is this line, y equals x plus 1. That is the equation of the slant asymptote right here before you get your remainder. So I'm going to erase that, and I'm going to graph that line in green so that we can see it, and then I'm going to do a sketch of the graph once I tell you what the signs are. So x equals x plus 1. That's a y-intercept of 1, up 1 over 1, up 1 over 1, up 1 over 1. So the line looks like this. Oop, that's not there, right there. So this is pretty accurate. Okay, that's what the slant asymptote looks like, and that occurs when the degree of the numerator is greater than the denominator. So now if I use a sign chart, I know at this point at 0, my function is 0. I know at this point, which is positive 1, I know my function is undefined. I need to figure out what's my function look like to the left of 0, and when I put in values, I find out that it's negative. And then I need to figure out what does my function look like between 0 and 1, and if I put in like a 1/2, I figure out that it's actually negative. So that means the function comes up, it touches, and then it comes back down, and it hugs those intercepts closer and closer. Now I need to figure out what's the function look like from 1 on, and if I pick some values, I find that it is positive, and I know that it's got to look something like this. And if I go to Desmos, and you can see that, that's exactly what the function looks like. So let me put in the slant asymptote. Well, first the vertical asymptote is x equals 1. See that? And then the slant asymptote is y equals x plus 1. Let's see how it hugs those. Pretty cool. I think it's pretty cool. All right, we got one more. Try E, and this will be our last one. Make sure you come in with this note guide. It's complete. Thank you.